Let's study the topic orthogonal unit vectors. Orthogonal means perpendicular. Unit means whose magnitude is 1. So let's define vectors which are perpendicular. Okay, and magnitude is to 1. Means those vectors which are perpendicular and whose magnitude will be 1 are called orthogonal unit vectors. Okay, clearly here orthogonal means perpendicular, unit means magnitude 1 vectors. Okay, vectors which are perpendicular. Okay, suppose for example we can say there are two vectors, vector A and vector B. Okay, there are two vectors in a plane and they are perpendicular to each other. Okay, they will be perpendicular, they must be what, perpendicular to each other. Okay, perpendicular to each other and magnitude equals to 1. If we will get magnitude equals to 1 and a vector perpendicular to both, perpendicular to both. If we will get a vector perpendicular to both A and B and magnitude is 1, then the vector will be orthogonal unit vector along A and B. Okay, how to find orthogonal unit vector? What the formula is? Simply at first we should see which operation makes a perpendicular vector along A and B. That is simply cross product. By cross product we get a vector which is perpendicular to both A and B, that is orthogonal condition met. And now to make unit vector we divide it by its magnitude, means dividing it by cross product magnitude. This will be that is, let it denoted by you. Orthogonal unit vector equals to A cross B by mod of A cross B. Okay, dividing this vector, this by cross product we will get a vector and divide this vector by its magnitude. Simply divide its vector by its magnitude, we will get unit orthogonal vector. Okay, means this vector will be perpendicular to both and its magnitude will be 1. Okay, this is the formula. And one other example of orthogonal unit vector is, we know in 3D Cartesian system, in 3D Cartesian coordinate system, what happens? This coordinate system means there are three axes, x-axis, y-axis and z-axis. Along x-axis we know it is I cap, along y-axis we know it is j cap, and along z-axis we know k cap. These are I cap, j cap and k cap are unit vectors. In 3D, three-dimensional coordinate system, I, j, k are unit vectors and they are also orthogonal because everyone is perpendicular to each other. Although they are three, but they are all perpendicular to each other. Here this is a formula for two vectors only. Okay, this is for two vectors. This is one example of three vectors. Okay, now let's see what can be the properties of orthogonal unit vectors. What can be the properties? Simply magnitude will be what? Property number 1, magnitude will be 1. We can write magnitude will be 1, we know. And another property, if we think it, we also know theta here is 90 degree. In orthogonal means perpendicular means theta 90 degree. Okay, if theta will be 90 degree, then dot product will be what? Dot product will be 0. Because if we will calculate AB cos theta, AB cos 90 degree, cos 90 is 0, then this complete term will be 0. So dot product is 0. Okay, and for cross product, what it happens? Let's see on different page. For cross product, we see, let it be, that is, let us draw it once again, x-axis, y-axis, and it is z-axis. This is I, this is j, and this is k cap is along z-axis. Now we see there are two types of characteristics. One is anti-clockwise movement, anti-clockwise counting, you can say anti-clockwise, and another one is clockwise. Two types of readings are taken for cross product. Anti-clockwise means what? Opposite of the clock runs in this way, that is clock runs in this way. Okay, and anti-clockwise means in this way, opposite of the clock movement. Okay, if it is I, if it is j, I am writing simply I, j, k. You will understand it I cap, k cap. Okay, I am simply writing I, j. Here in anti-clockwise we should remember one thing, it is having plus sign. And for clockwise, we should remember one thing, it is a minus sign, okay, negative, that is negative. Here it is positive. How it is negative positive? Let's see. That is read it from I cross j. In cross product, what we do? I cross j, that will be equal to k, positive k. And here in clockwise, I j k. I cross j will be what? I cross j will be, sorry, we are reading clockwise. Sorry, I cross j is anti-clockwise. Okay, this is, we will read j cross I. Let's start from I cross k. We can write cross k. What will be the value of I cross k? This is anti, this is clockwise movement, this is clockwise, it will be minus j. Okay, the cross product of 2 will be the third. Here also the cross product of the 2 will be the third, but the signs are considerable. We have to consider only the sign according to clockwise or anti-clockwise motion. Sorry, clockwise and anti-clockwise observation. Okay, then in anti-clockwise it is taken as positive sign, that is positive k, and in clockwise, when we read it clockwise, that is I cross j, this is this type of motion, that is I cross j, that will be I cross k, that will be j, but with minus sign. Okay, so here I cross j will be k, j cross k will be I, j cross k will be I cap, and k cross I will be what? K cross I will be j, k cross I will be j. Okay, and here it is I cross k equals to minus j, k cross j will be minus I, k cross j will be minus I, and cross k will be minus k, j cross k, j cross I equals to minus k. Okay, this is the way we do it, the cross product. Okay, now let's see one example, one question for you. If you have to find a unit vector that is orthogonal to the two given vectors, suppose the two vectors are given as a vector a equals to I cap plus j cap and vector b equals to, let it be I cap plus k cap. They are the two simple vectors are given. Okay, find, this is the numerical, two vectors are given, vector a and vector b. We have to find unit orthogonal vector along the two given vectors. Means we have to find a unit, or orthogonal means what? Perpendicular. The vectors should be perpendicular also, means theta equals to 90 degree. Okay, and perpendicular also, and magnitude should be 1. This we have to find. Okay, we have already studied the formula that if we have to find a vector that is perpendicular to the two given vectors, then what we do the operation cross product. So we will find the cross product. Okay, and then magnitude, to make the magnitude 1, what we do? We will do simply divide by its magnitude, the magnitude of the same vector. This is also a vector, a cross b, the result will be a vector, so this is also called a vector product. Okay, and so we will divide it by its magnitude. The formula we have already studied. We have to find this vector u equals to this. So this is the desired result, and for solving this we will do what? Separately we will find vector a cross b, that is equals to determinant form. We will do it I j k. This is simply mathematics. Then this will be along I, this is 1, along j it is nothing written, it means 1, along k this is it has no k term, so it is 0, and looking at this I, that is 1, j is not here, so it is 0, and k is 1. Okay, solving this we will get how much? Let me do it. Then it is this, so it should be I cap minus j cap minus k cap. You can also write cap, and then there is, okay, then it is this vector we got, and so a cross b magnitude will be what? Vector of a magnitude we know, we find it by this way, that is equals to root 3. Okay, so this term and this term are got, then just put it here. After putting we will get I minus j minus k by root 3. Expand it, I cap by root 3 minus j cap by root 3 minus k by root 3. This is the desired vector answer. Okay, this is one important question. It comes in examinations. Two vectors will be given and we will have to find a unit vector that is perpendicular to both and whose magnitude will be 1. So a unit vector, for any two vectors, A perpendicular vector will be found by this term, that is by vector product A cross B in this way. This will be the vector which is perpendicular to both these vectors. Okay, but the question says unit vector. That perpendicular vector, it must be a unit vector also. To make it unit vector, we divided by its own magnitude. Okay, this magnitude is found only to just make it a unit vector form. Okay, and so we did here and we got it. Okay, thank you. Subscribe the channel please.